Hey there, this is Pete LeVasseur with the Rust content team. So I had the chance to sit down today with Bart here at RustConf 2025 in Seattle. So yeah, I really want to thank you for the time, sitting down with me.
Happy to.
Great, and let's jump into it. So
Sure.
could you tell me a little bit about yourself, how you've been involved with Rust, kind of your path, your journey to get here?
Sure. I mean, I go way back. I started doing computing in the 70s during the sort of microcomputer revolution, and have always been interested in things like low-level and embedded and in programming languages. And so after a long and varied career of doing system administration and working as a DSP programmer and building tools and programming languages and stuff, I started programming C in the mid-'80s sometime. I started programming in standard ML in grad school, and then in Haskell later at Portland State. So by the time I'm a professor, I've kind of played with a lot of things, got super interested in a lot of things, and then Rust came along, and because Portland, I was exposed to it from pre-1.0 and got to see some of the sausage being made, because some of my students got really heavily involved in the project. People like Josh Triplett and Jamie Sharp also helped introduce me to Rust. My friend Jim Blandy wrote a very, very good book, which is still being published, Programming Rust, which gave me the opportunity, the excuse to start teaching Rust. I said, okay, now I have a textbook, which I couldn't really say before. And so I started teaching Rust, I want to say 7 or 8 years ago now, and have taught a few hundred students Rust over that time. I've also started teaching more recently Rust Embedded and Rust Web Dev and full stack web dev, and have contributed to the project in very small ways and tried to help out where I could. I'm really excited about Rust. It, to me, is a super sweet spot between some of the great things about Haskell and some of the great things about low-level languages, C and whatever. To me, I have projects in all of those languages and have contributed to all of those languages in various ways, and I'm very happy where I am right now. So yeah.
Got it. So yeah, like you kind of found Rust, and now you're like, okay, pretty happy contributing to this space.
And using this space, and
Yeah.
it's answers a lot of the questions I had about why do programming languages have to be like this in some really, really positive ways. So.
Nice. So yeah, you touched on this. So you're an educator. You've had a chance to now teach some courses using Rust and see a number of students kind of along their journey starting out with Rust. Whether they started, stopped, or did something in between with it afterwards is neither here nor there. But when they were kind of getting into Rust and starting to learn it, I'm wondering if you saw them maybe face any particular challenges, or were there any teachability issues that kind of cropped up?
Yeah, especially early, right? People forget, our reputation for being a hard language to learn is conditioned partly by how hard it was to learn near 1.0, and people miss a lot of the little sharp corners we've shaved off in the last 10 years that were real problems. NLL, for example, the new lifetime model that we did at some point just was revolutionary in removing 1 billion examples of, oh yeah, Rust won't let you do this, because borrow checker. All of a sudden, people would try those examples and they'd just work, and you're like, oh, okay, never mind. And that's just one example. We've done a whole bunch of stuff with the ergonomics of the standard library that have been really, really helpful. We've done a whole bunch of stuff, there again, try was not a thing when I started teaching, and then try was a macro, and now try is question mark, and the world is a much, much better place for that in Rust error handling. And I could go on and on with examples like that. There are still things. When Async await came along, I cried a little bit, because Async await is by far the hardest thing to teach and learn in modern Rust. I understand the reasons why it's there, but it's a challenge for us at this point. And that's especially true given that Tokyo is a whole thing, and that's really everybody's normal choice of async await libraries. So yeah, there's still learnability challenges, absolutely, and there's more new small things cropping up, but the trend overall has just been toward better and better learnability. The other thing that's happened during that time, and I'm sorry if I'm going on longer than you like, but the other thing that's happened during that time is we've gone from very few materials. Like I say, Jim Blandy comes out with this book, and I'm like, oh wow, there's a book, other than the sort of the Rust programming language, which is a great book, has been around for a long time, but isn't adequate to teach a course from, especially then. And all of a sudden, we start to see more and more written materials. We start to see more and more informal materials. There's more and more and better examples. The quality of crates and documentation improves, so you have to invent less of the world for yourself. There start to be videos. There start to be all these resources, and so even if it were still as hard to learn in 2025 as it was in 2016, it still wouldn't be as hard to learn because there's a bunch of people here to help you.
There's a lot of materials.
Yeah, there's a lot of materials, and there's a lot of people.
Showed up.
I want to be really super emphatic about the fact that materials are great. Lots of things have materials, but unless the materials are backed by people who are eager to help you and improve the materials, improve your experience, talk to you personally when you need it, it's a lot less valuable. And that's what we've got with Rust is not only do we have great materials, but we have people who are not just willing but eager to answer your questions, to help you untangle with stuff. And when you point out, this documentation doesn't seem right or it doesn't help me, everybody's like, well, let's fix it, There's no other language I've ever seen in my long, long history with many, many programming languages that's been more excited about fixing the compiler error messages. That's a thing that everybody talks about. They're like, well, I came to Rust and everybody told me it'd be hard to learn, and then the compiler was just telling me what was going on and how to fix my code. I'm like, yeah, that's Rust. And if it doesn't, if the compiler's like, no, do this wrong thing, you report it and somebody looks and they're like, oh yeah, we should fix that. That's important, right? Nobody has that culture as far as I'm aware except us.
Yeah, so to your point, like it's maybe the underlying culture there for the Rust community of being welcoming and being open has made its way into these different parts of the language and the compiler, like the compiler error messages, to really kind of guide you, hold your hand along the way.
Most technical things in open source, one of the ongoing problems with open source for the last 20 years anyway, has been this contributor cliff, where nobody's really interested in your contributions until they reach a certain very high technical level. And Rust has the gentlest contributor slope, again, of practically anything I could name, and that includes very friendly things like Python. We are happy to have your help if it's only documentation or if it's only trying stuff out and giving us reports, right? We're happy to have any kind of help you can give. And so because that slope is gentle, some of those people do turn into very hardcore technical contributors at a fairly reasonable rate. But even if they don't, we're still all having big fun together and being happy, right? Nobody's looking down at you because you're just the document. What? How does that even make sense?
Right. It's not like a sheer cliff where they're having to sort of rappel their way up.
There's no technical meritocracy, a term that was once used as proudly in open source. It's not one of those where if you're not technical, you clearly aren't of merit, right? I mean, that's always been dumb, and nobody has ever thought it was smart, but it's easy to fall into.
Got it. So something that stood out to me, you were mentioning about async await still being, I think you had mentioned it's still a challenge to kind of teach and kind learn, of get folks into it. Have you found any particular materials that are helpful for this, or communities people can kind of dive into?
I wish I had a better story to tell you. Jim's chapter in Programming Rust on this is very, very good. It's a fantastic chapter. The problem is that async wait, much more than the other parts of the Rust language, is a Eloy and Morlocks kind of situation. The Eloy get to use async await, and that's not too hard to teach. You put a wait here. Yeah, you're going to have cancellation problems, and yeah, mutexes, blah blah. You're still up full of footguns more than the rest of Rust, but you can teach around those and make them work. The bottom half, the Morlock half, I don't even really understand it, so I don't know how to teach it to anybody.
Things like the executors.
Yeah,
and like how to write
exactly. All the very complicated pattern of callbacks. I've used futures or whatever you want to call them in a lot of languages, right? And Rusts are necessarily harder than anybody else's because doing it without we're the only people I can think of who've done it without a garbage collector. It's absolutely that your promises or futures or whatever, well, that's why you need a garbage collector, is to keep all this stuff alive, when you're doing a bunch of these at once. And we're like, nah, we're not doing a garbage collector, but we're doing them anyway. And so it isn't like, no, this is not a knock on the implementation, but it does mean that the machinery under the hood is pretty special.
Gotcha, yeah. So if you kind of need to be more of like a user of like certain APIs that might be async, like you're kind of in for an okay time.
Yep.
Like there's ways to work around certain things,
Yep.
But if on the other hand, it is your job to implement things that maybe the lower layers.
And fortunately, Tokyo and its friends take care of a lot of that for normal code. But my most exciting place to use Rust, to use async await in Rust, my favorite place is Embassy, which is an embedded library that makes heavy use of async await. Embassy is amazing. It really fills a gap between bare metal programming and a real-time operating system that is a good gap to fill, and it's a really, really cool tool. But now you're going to be implementing interrupt handlers for strange devices that have to be the bottom side of async await. I hope you are prepared. And the Embassy guys are great and will absolutely help you with that. But here we are.
Gotcha. Yeah, so you had mentioned that like one of the passions that you had was for embedded, and you've got kind of this long storied past with embedded. How is the teachability story for Rust and embedded?
It's really good. So here's the thing. The Rust embedded community, Jose Aparicio and some people, set up a really interesting experiment for Rust embedded in which the type system was really taken seriously, and there was a lot of type state stuff and that sort of thing that was designed to really, really try hard to catch everything you could catch at compile time. The compile time of the standard Rust embedded environment is a very strict compile time that will catch mistakes you wouldn't think that a type system would catch. So for example, every pin in a typical implementation has its own pin type. There isn't a pin type for pins, there's a pin type for this pin. And why? Well, because some pins can be used in some ways, some pins cannot. And so if my pin is connected to an analog to digital converter, if I'm trying to talk to an analog to digital converter and I accidentally specify a pin that isn't an ADC pin, I get a compile time error that says, no, you can't do that. That drives people frickin' nuts. The other one is the ownership thing. Every peripheral and every piece of that peripheral is owned exclusively, and so if two things try to work with the same stuff at the same time, that's just not something we really support. That drives people nuts not because that's a good idea, but because the machinery to enforce that gets in the way of just, seamless programming, right? So there's this initial barrier of this is all weird and awkward and I just want to write through pointers like I did in C, and why are you doing all these things to me? But for people who are new to embedded as well as newish to Rust, which are the people I'm teaching, what it means is there again, you get these compilers. It's like, Bart, why is there a compiler? Well, because you're trying to do something you shouldn't try to do. That's a way easier story than, Bart, this pin doesn't go when I run this program. And you're like, yeah, well.
Or it sometimes goes,
yeah,
sometimes
goes, sometimes doesn't, which is even worse. But usually, remember, embedded programming at the lowest level, embedded is one of these terms, right, that has so many connotations at this point. It's
Right.
embedded, but it runs a full Linux kernel. It's like, well, I guess, But anyway, this very low-level bare metal embedded, your classic problem is that when you do need to debug something at runtime, it's going to be a whole adventure just finding out what's going on, right? It isn't like your console messages will tell you anything. If you're lucky, you have a serial port hooked up. And if you're really lucky, you've used the Rust embedded infrastructure, which is amazing for getting panics to come out that serial port. But a lot of the time, you're like, yeah, this pin doesn't change state when it's supposed to. It can be really hard to step through it. There again, we've got a good remote debugging story. But the point is, it's especially a case where if you catch things at compile time, you're really, really happy to catch them there rather than later when they're hard to figure out. And, embedded shares with some other things the property that you're trying to build really high reliability stuff sometimes in this kind of an environment. And the problem is that if you do it wrong, like you say, it'll work right for literally a week. And then a week and 1 second later, it's like, nope, sorry, we're not doing that anymore. And, catching that kind of stuff at compile time can save you, having to implement a whole OTA firmware update structure, right?
Right, makes a lot of sense. Yeah. My background is in automotive, where embedded can indeed span that range from something that is running at like exotic CPU architecture and is like glued together and stuck somewhere and forgotten about forever to something that's a little bit more powerful. So are there, so to your point that you raised earlier, it's not just about materials, but it's about community. Are there places that people could go to learn more about embedded and Rust?
The Rust embedded working group I'm proud to be a humble member of this thing, is got a matrix channel that's open 24/7 and a whole bunch of related matrix channels that are absolutely a good place to go meet people. We've got a bunch of stuff online. I'm the editor of the Rust embedded discovery book for the Microbit 2, which is, I didn't write it, but I wrote a little bit of it and am editing it.
A micro part of it.
Yeah, a micro part of it, exactly. And I did some reorganization. Anyway, that thing is our intended entry point for people who want to learn Rust embedded. You'll have to buy a specific board because we chose to do it that way, but it's the BBC Microbit. It's $20 and is available literally everywhere. And when you have that board, we walk you through pretty much all of the key stuff of getting started with Rust embedded. That's a bare metal book. Again, you can grab the Microbit and start out with Embassy and work through their documentation if you want something a little higher level. But yeah, embedded tends, like you say, from your own experience, to be invisible a lot of the time, and it's kind of invisible-ish in the Rust project too. I'm really pleased to see talks here and things like that, but we encourage people to try it out. I mean, that's the thing. Right now, another project I'm working on, I managed to nerd snipe Phil Opperman, and I'm very proud of this, into working with me on updating a Rust OS tutorial that the embedded working group maintains. And my goal was to make it run on the Pi 02W, because I said, the problem with most of the OS tutorials is you need to dedicate a laptop, and people can't afford to dedicate a laptop, and it probably has to be a particular laptop because drivers. It's like, no, let's just do it on a board anybody can buy for $15. And we're making good progress on that. And so is that embedded? I think it is. And in fact, the next iteration after we finish this one will be going back and integrate it into the Rust embedded space. Anyway, the point is, I think we have a good story to tell about teaching people things, about figuring things out, about setting people up, but publicity is maybe the hardest part of the story, and onboarding people to help. Yes, publicity, thank you. And please come help, get anybody to help. We are always looking for more people to do more things. It's, one of the problems with the Rust project, and I will let you get on to your next question, but one of the problems with the Rust project is that, I kind of hate the term bus factor, but our bus factor in the Rust project is one or less in so much of the ecosystem. We've done an amazing job in 10 years of spreading in 1,000 amazing directions, but that means that, you know, the famous XKCD that everybody talks about with the guy in Nebraska holding up the whole world, our whole project looks like that guy. And we've got the whole project sitting on all these, it's all stilts all the way up, right? At any point, the Jenga tower can get in bad shape. And so it isn't just that we don't want to move people from the other parts of Rust where they're already contributing successful. We want new people to come in and say, hey, I'm an embedded person and I'm willing to learn Rust. Why don't I help out while I'm doing that? You know, and I think a lot of the project needs that. You know, we're scaling ahead of our population a little bit just because we've been so successful at what we do.
The curse of success,
yes,
and running
exactly.
in 1,000 directions, some things get a little bit thin.
Everything
in
gets a little bit thin.
Yeah.
I don't think there's any place where people are like, oh yeah, we've got enough people right now, we don't need any help. You know, find that in the Rust project and let me know.
Gotcha.
And there's a bunch of places where you can find people who are like, no, we're desperate, we can please, you know, some of our most amazing tools, some of our most amazing infrastructure, right? The number of people contributing to Rust format, the number of people contributing to Rust doc, you know, the number of people contributing to a bunch of this stuff is just like, wow, how did you do that much with that many people? Well, because they're amazing, but you know,
it's a sustainability question,
it's the
right?
sustainability and the growth question, right? They're like, why don't you add all these features to Rust format? It's like, well, because we can barely keep it running. There's only so many of us. And the embedded working group, and that's, I will circle back, is that there's a whole backlog of why don't you do this amazing thing? And we're like, we want to, but we have to do these other 15 things.
And you say, well, you look like an amazing person that is requesting this. I would love to work with you and have you do that.
The term pull request welcome is always intended sarcastically in modern open source. We mean it. We're like, no, really, pull request welcome, please.
Here's the issue, we'll coach you.
Let us help you guys. Let us help you figure out the pull request 100%. And that's kind of how I ended up doing documentation stuff for Rust Embedded. I'm like, I'm teaching this, I need the docs anyway. And you know, most of the documentation, and again, this is not a diss on anybody, it's just a reflection of the workload. Most of the documentation hadn't been touched much for a really long time because everybody's too busy.
Everybody's trying to kind of keep the lights on.
If you have a choice between improving the documentation or keeping the code running, most people will choose to do the second thing.
Makes sense. So another thing you'd share with me is you've had the opportunity to do some teaching remotely to some folks that are in Africa, and I'm curious if you could share maybe your feedback, your learnings that you've had, maybe unique situation there.
This is really early. I've only taught a couple of classes into that, so I can't give too much about how it turned out. I also have done remote trainings before and that sort of thing. I've done some industry training stuff just for fun. And I'm a big fan of remote. I've also taught remotely at Portland State. My fall Rust class that I'm about to start teaching will be a remote course. I love teaching Rust remote. I get the whole personal touch argument and blah, blah. But I'll tell you this, being in the room, in my experience, is not as good as being in the chat. I can have people asking questions, discussing, all those things while I'm talking, and I can stop and catch those things at my leisure, and when it's good to do that. And to me, that experience is in a lot of ways a stronger experience because it's more interactive. You know, I don't want a monologue. You may not believe it listening to me now, but I don't want a monologue. I want to talk to people, and this gives me a chance to talk to people. The Rust Africa thing, though, I should say something about just because Mordecai Ekutudo and his people have put together an amazing program covering many African countries. It's not just Nigeria where he's based. And he has a document that he wrote at my behest that I haven't edited and gotten out anywhere yet, and I feel really guilty about it, that talks about the differences in culture and education and everything else between the different countries and regions of Africa, and what the situation is there. I mean, it's a cliche, but it's also true. It's a cliche because it's true that it's easy to forget about Africa when you're talking about technology, because it's sort of out of a lot of loops, but there's people there who are so eager to learn this stuff and so excited. 170 people for this thing. I don't know how, partly because Mordecai is amazing, but partly just because that's how it is. And our big bottleneck right now is that, like I say, the board we want to use for this Rust Embedded I'm teaching is $20, and so we have to, and most people can't afford a $20 board there. And so I shipped some boards from some money I had, thank you FutureWay, but also we're looking for more money to ship just so we can buy $20 boards for people so they can try this stuff out.
Right.
Some of them are programming literally on their phone. So I don't want to sound all, white saviory. I hope that isn't how it comes off, but I am really excited to see that taking off there, and I think it's a place where they'll be giving back sooner rather than later, too. So I'm as eager to have them help us as the other way around.
Nice.
And glad to have them looped in.
Nice. Yeah. I've had a chance to speak with a couple folks from Africa that are using Rust in these different regions, and it's really fascinating, like learning those cultural differences.
Totally.
And reflecting those things into maybe some of the teaching materials that we have and some of how we go about things. And it's very admirable to get things down to a $20 device. I guess your weekend project is get it down to a $5 device or these sorts of things, right?
We absolutely could find $2 devices we could teach this stuff on to some extent, and maybe someday we rewrite the book for that. But I don't want to derail the discussion, but the trick of choosing the right device to teach embedded Rust on turns out to be a real trick. When we started, we were teaching on an embedded board, an STM Discovery. The reason it's called the Discovery book is because we taught originally on the STM Discovery board, which is a real nice board and even a little bit cheaper than the microbit. But during the pandemic, they became kind of unobtainium because supply chain, and also at some point, STM switched the inertial measurement unit on that board without changing the model number. So depending on which board you got, your software might need to work differently.
SemVer for hardware is still kind of coming up.
Exactly. Okay. and so part of the reason we made a decision to move to the microbit is because open hardware, you can get full schematics for it, which is kind of amazing. Absolutely used well outside the embedded, the normal embedded community. It was really original. It's aimed as it's literally the British Broadcasting Corporation did this board, and its normal clients are MicroPython and literally blocks programming, scratch-like blocks programming. You can do that and then compile it to code that runs on this little embedded board. It's hilarious. And so this is a board that we know will be around for a very long time, and that we know people will be able to get, and that we know that people can find out literally everything about how it works. And so we're unlikely to move off it anytime soon to some more ephemeral thing.
Yeah.
That was a whole sidetrack that you probably didn't want nor welcome.
No, I mean there's a bunch of constraints that go into building out
teaching
material
is awesome, and I love doing it, but a lot of the planning I kind of hate because it's this kind of thing. You end up going down these rabbit holes of, what do we want to accomplish, and how are we going to accomplish it under weird constraints that you just don't think of when you open the book, right?
Right. That makes sense. So pivoting a little bit, you'd share with me that something that would be interesting to see kind of blossom is WebAssembly really taking off.
Very excited about WASM.
And I'm curious to hear from you, like, what do you see on the other side of that? Like, what role might Rust play in that, and what are the impacts?
Well, I mean, right now, Rust is the premier WASM authoring tool. There isn't anything that's close that I'm aware of. I guess writing WebAssembly by hand would be a thing, but if you're going to write in a high-level language, it should be Rust for WASM. So that's the tie to Rust here. My fantasy, one of the things that we talked about in the pre-thing is, what's a unlikely but big if true kind of thing.
Yeah.
look, I bless the people who did JavaScript and best the people who use JavaScript. JavaScript is absolutely a cultural phenomenon. And right now, if I want to write a full stack web app in one language, it's pretty much got to be JavaScript, because that's the only thing that's running both in the browser and on your server. For a whole bunch of reasons, I fantasize about a world in which that one language is Rust, that I write Rust WASM for the front end and I write Rust for the back end, and I get all the speed ups and all the reliability improvements and all the forward compatibility and low CVEs. You know, I get all those things that the Rust ecosystem provides me with while being able to write full stack web, because the web will be with us for a long time and people aren't content, as much as I think they even should be, as a guy who grew up with, you know, the starting of the web, in just having a server-side app, right? HTML5 is amazing, and it lets you do a lot of things without any code on the front end. You know, and I wish people were better about, especially with CSS, I can even style it without any code on the front end. I wish people would take better advantage of that, but if they are going to put code on the front end, I would much rather have it be Rust WASM than JavaScript.
Got it. Yeah, so I guess there's other technology like TypeScript, for example, right?
Well, TypeScript's just JavaScript with a weakish type system on top. I mean, it's still JavaScript.
Yeah. Do you have, so it sounds like you have some thoughts around that like maybe it's not quite strict enough, doesn't quite go far enough.
Well, yeah, I mean, nobody who's used TypeScript thinks it's a substitute for a full-on static type system, and it's very limited in its expressivity. It's certainly better than writing JavaScript without it. There's no question about that in my mind, having tried a tiny bit of both, but it doesn't solve any of the fundamental problems. And like I say, it certainly doesn't solve the performance problems. It certainly doesn't solve the security problems. It certainly doesn't solve, you know, the sort of large-scale maintainability problems. JavaScript's module system, and TypeScript's, is utile, but Rust is way better. You know, the modularity of the Rust ecosystem is one of its big hidden strengths. You know, and I really want that in a way that even with NPM we really can't provide, as far as I can tell, in the JavaScript world. So that's one case for WASM. I have plenty of cases for WASM. The second case for WASM is that it's very fashionable now to point out all the problems with this, but I am still a big believer in my heart of hearts in plugin systems for programs being written, you know, plugins being built in WASM. To me, WASM is the natural plugin language. We're in a place we haven't been for 20 plus years, where server-side and on the desktop, there's more than one CPU architecture we have to think about. We thought we'd killed that, and the x86 and AMD 64 architectures were the winner, and you didn't have to think about anything else. And now we have ARM, we've got RISC-V. We've got to think now about cross-platform plugins, right? And we have to think about cross OS, cross service plugins as well. And as a guy who's very excited about audio, and has been for a long time, it's been a professional job of mine in the past and is something I do a lot of. You know, all these plugins, audio plugins, that only runs on x86 Windows boxes. It's like, really?
On the Blessed platform.
Yeah, on the Blessed platform. And the Blessed platform is probably an x86 Windows box. And again, I'm a Linux guy and have been for a long time, and so that hurts me a little inside. But now especially, I might be a Linux phone guy or something where, you know, it's like, I really need it to run on AR64. It's not going to work.
Yeah, it makes sense. Like what you had raised up before about, Rust being able to be used like maybe in these different places, like front end, back end, these sorts of things, and embedded and tool building, all these things. I think the WASM story makes a lot of sense from that perspective. It enables it in places that you might not think of off the bat, such as like, Visual Studio Code, like VS Code plugin, right? Like you can write those in WASM.
People forget, 20 plus years ago, Microsoft used to ship a lot of their web plugins for front-end browser stuff in ActiveX. And ActiveX was just a bunch of x86 code, completely unchecked, completely anything, right? And it was a complete freaking fiasco. And the move from that to JavaScript just absolutely changed, for the better, the way the web worked, right? As much as I'm kind of sketchy about some things with JavaScript, if the choice was ActiveX, no, JavaScript, 100%.
I wasn't aware of that background with ActiveX. Wow, okay.
Yeah. Go look at some of the vulnerabilities that happened with ActiveX. And, the biggest victim of that was Adobe Flash, which is essentially shipped against that technology. The fact of the matter is that a whole bunch of things that are concerns in current year are tangled together and make some of these changes kind of very, very attractive that have always been a good idea, but now they're almost an imperative idea. Security is a bigger deal than it's ever been before. Reliability is, we have higher expectations for reliability than we've ever had before. People don't remember, during the 90s, when your app crashed, you're like, yeah. Of course.
Is it Tuesday? Is it Wednesday?
Written on the
Thursday,
wall
right?
of the room full of Macintoshes that I was at near the end of my time at Reed was, Jesus saves every 15 minutes.
I think it's a rule we can all live by.
Yes, absolutely. So. But a rule we don't have to live by anymore, damn it, because we've gotten better than that, and we need to keep getting better.
Yeah, the expectations have gone up, the sophistication has gone up, and so Rust in that way can kind of undergird that, right? And allow building of systems like that. Yeah, it makes sense. And so we've talked about, sort of a lot of positive things about the project, the ecosystem, the language. I'm a bit curious to hear about if there are things that have been frustrating or been kind of a thorn in the side when trying to use Rust or teach Rust, things that could be improved, smoothed over.
I mean, yes, obviously, and the problem is I can now give another 30-minute monologue, or I can smile and say yes, and I'm going to do the second thing. I will say that Josh Triplett, my friend and former student, and I have, over the last month, been constructing a list of things that I personally wish were different in Rust from teachability or usability perspectives. I've got about 20 things on that list, and every week I think of one more that I probably should have added from the beginning. What I would say about that is, again, the Rust community is special. And part of the reason I don't want to air any of that laundry in public is because I think people are very interested in figuring out how to fix pretty much every one of those things.
Gotcha.
And again, it's a question of people. We just don't have the people. But if we did, I think all 20 of them would be fixed in a month or a year or something. I mean, one of Rust's real problems that we made for ourselves, and I love it, is this problem of having a very strict, like you say, semver, addition change, backwards compatibility, forward compatibility story. And that's fantastic and super important, and it makes it really hard to fix things. And so to the lack of personnel, you add the burden of going, well, yeah, but we have to do it in a way that either we wait 3 years and then hope that it doesn't disrupt people too much, or we try to fix it now in a way that basically disrupts nobody. That is challenging as hell, but people are taking on that challenge in a lot of places. I just had a really interesting discussion randomly last night with a couple of the people in the project, and again today, and a couple of people at the heart of the project about a feature I've wished for since literally I started using Rust, that they're now kind of trying to figure out how to do and stabilize. And it's taken 10 years, but that's not that long in the life cycle of a good language.
Yeah. If you succeed, it will stick around, and these things they'll get smoothed out.
And especially when you have a community, like I say, that's as friendly and low ego and high commitment, to working together to succeed as any language community I've ever worked with. And that's a big statement, because I've worked with a bunch of them. I am so impressed, with sort of that aspect of it. You know, what I've been telling people, I'm sorry, again, I'll ramble until you stop me, but what I've been telling people lately, because I really feel it, is when I started with sort of capital O, capital S open source 25 years ago, when it was really taking off in Portland, which Christian Science Monitor said was the open source center of the world. Woo. The thing I really treasured the most was that there were 40 or 50 of us in town, and people from all over the world, don't get me wrong, but in town even, who absolutely cared for each other and cared about what each other was doing, and we were all supportive of all our stuff that made sense, and when something didn't make sense, we weren't shy about telling people, but not in a mean way, in a loving way, and if they disagreed, we still loved them. And you know, that sort of hippie-esque open source movement of olden times, as somebody who's part hippie myself by acclimatization, I really treasured that. I really love that. And to a certain extent, the current Rust community feels like a bit of a throwback to that era. I feel like we're reviving something that's been dormant for a long time. I mean, to me, well, yeah, we're reviving something that's been dormant for a long time, and I think that is as much a key to the success of Rust. You know, you don't become the most loved programming language in that survey over and over just by having a really good language. You become that by having really good people, so that when you interact with the language, everybody's like, oh, hell yeah, this is, you know, I was mean to them and they were nice back. That's how you win converts right there. You know, so, yeah, I would hate to see us let down things technically, and I think there's a little risk of that, but I also would hate to see us let down that community spirit, and I think there's a little risk of that too, so I'm very happy here.
Nice. So speaking of hippiness and speaking of keeping things like empathetic, caring about one another, one of the things that you'll be doing at RustConf here is you'll be running the unconf, and you've been doing this for a few years now, I think. And you were schooling me a little bit on the old school like ethics of and like way of doing
ethics, but the old school
like,
process. Yeah,
process. And like the way of doing this. I'm curious. I just got to know a little bit more about it.
Yeah, of course, because I think it's a good example of what I'm talking about. You know, back in the early 2000s when I went to my first unconference and saw a few more, it was a new thing in the world in a lot of ways. I mean, it had been going on in some spaces for a little while, but literally it was at the point where they had an organization, Open Space, that trained facilitators, and you could pay to fly a trained facilitator to your unconference to run it. And it was amazing. It sounds stupid, and it was really awesome. And they had a whole process book, and they knew what they were doing, and it was very hippie and very friendly. And it made the experience something special. It wasn't just another kind of damn conference with people talking at each other. And I'm trying to be really sort of careful about what I say, but let's just say that over time, as we technologists took over running the unconference thing, we kept doing it because it's obviously valuable, but we let a lot of the process fall away. We turned it into more of a mechanized activity to have a conference, you know, and I feel like a lot of the spirit was lost. And so when I got a chance to start running unconferences again a few years ago at RustConf and some other places, I just jumped at it because I'm like, I want to bring some of that back. We will absolutely have a little opening ceremony and a little closing ceremony tomorrow, and that will be part of the experience, and you will like it. We will absolutely talk about the laws of the unconference passed down through time, which is a thing that you should talk about at the start of your unconference. You know, this kind of stuff, you know, as technologists, I think a lot of times we miss the value of it, and when it's gone, we forget about it. And that's kind of my job as an old man, is to preserve the memory of some of this stuff and bring back the stuff that's valuable and leave the stuff that wasn't behind. And so, you know, that sounds pretty grandiose, but that's what I'm trying to do.
Pass down the oral tradition.
Yeah, pass down the tradition of how things work in a way that sort of makes it more than just another day of RustConf, but makes it something special that people remember as a highlight of their year in a different way.
Yeah, I mean, I had the good fortune to be able to attend the unconf that you ran last year in Montreal at RustConf, and I really enjoyed it. And indeed, there's a ceremonial aspect to it, and we walk through things. And so, yeah, if you're ever at RustConf and you get the chance, yeah, by all means, sign up for the unconf. Hang out.
If you can get in, that'll be fantastic.
Hang out, do some hippie stuff, like tap into the software folks of lore.
Yeah,
so,
and talk about the things that matter to us as a people. That's the thing. When you get a conference, bless them. I speak at a lot of them. You're hearing about the things that matter to the speakers, and the speakers are talking about are selected on the basis of things that matter to the program committee, and that's valuable and it's good, but it's a lot different than the things that matter to the community of participants, and so that's the other side of that coin.
Yeah, absolutely.
I was on the program committee this year. It's not like I picked a side here, and I think what we did with the main conference, absolutely valuable, but I think this other thing's valuable in a different way too.
So if anything, you're throwing stones at yourself. You're throwing them up.
Exactly. If I'm throwing stones, they're at my own face, which is something I'm really good at, but...
Gotcha. Yeah. So as we kind of wind down here, I wanted to see if there were other things that you wanted to share about, maybe things we didn't touch on, resources or groups you'd like to point folks to.
I mean, I really, really, like I say, am eager to see people dive into Rust, but also see people dive early into participating in the whole Rust thing. This is not, in my mind, best as a bystander language, either for us or for them. This is best as a participant language. And this whole Rust is too hard, Rust is too technical, blah, blah thing is to some extent self-inflicted because, that isn't how you learn things. One of the things I tell people is, look, I'm in an incredibly privileged position in so many ways. And one of those incredible privileges I have is, like I say, I grew up with technology from the 1970s, right? I got to absorb these weird technical things one at a time as they went by. I got to Forrest Gump my way through some of the most amazing people and events in, the history of computing. So for me, I'm in a good spot. For you, you're trying to do all that in 2 years. Good luck with that. Don't expect that of yourself, A, but B, the way you accelerate that process is the same way I accelerated that process. You find the most loving, smartest people you can find, and you hang on to them for dear life, and you say, look, I'm not doing this by myself. Humans are garbage at learning by themselves. They're absolutely awful at it. Don't fall into that trap. Find some friends. If you're uncomfortable finding friends, learn that skill first, and then dive in with your friends to learn stuff and figure stuff out. When I was through my whole career, I've had people look at my code and tell me what was broken and why. I've had people tell me about technologies and watch me work through them until I got them figured out. Without those things, I was telling somebody just a bit ago, one of my first experiences, I got my first home computer, which was built by a company my dad started, crazy, CPM box, and one of the guys who was associated with that company, I get my computer at home and he comes over to my house because it's that kind of company. He's like, yeah, and besides my dad probably bullied him into it. And he's like, the video transistor on that board's backwards. And you'll get a lot better video if you turn it around. He shows me on the schematic, and he says, yeah, look, the silicon on the board is even backwards, but the schematic is clearly supposed to be this way. And so we got out a soldering iron. We pulled the board out, flipped that transistor around, and sure enough, the video got better, right? How cool is that? And how much is that kind of experience still replicable today? It's just hugely, but you got to reach out. You got to find it.
So what I'm hearing is the compiler error messages are great. They will be your friend. They'll guide you. But humans are also great, and community is also great for kind of going along that journey.
Yeah, absolutely. And if one of the reasons I think Rust is poised as somebody said earlier, to be the next 40-year language. One of the reasons I believe in that is because I think you have a unique opportunity to be in on so far really good community of a 40-year language, and you should take advantage of that. It's not something you should take for granted. Jump in on it.
All right. Well, I really want to thank you, Bart, for taking the time to sit down with me today, chat about Rust, education, and all these things. I'm sure we'll have some links or something. I don't know how to do YouTube stuff yet, so we'll have some links or something available to check more about the resources and the communities that you've pointed out. But yeah, again,
I should
really
put
appreciate
one last second plug in. I forgot.
Yes, plug away.
Rust-Edu.org. Go to rust-edu.org and check out my education-focused, not as far along as it should be, project in trying to bring Rust into universities. And join our Zulip and say hi to me, and let's do some stuff together. Sorry, go ahead.
Perfect. This is also a PR's welcome situation. So if you're an educator or if you're curious about Rust, this is a good spot to come by. Cool. So yeah, thanks so much for watching. I'm Pete from the Rust content team, and this was with Bart. So thanks, everybody. Bye.